Hey everyone, I wanted to put together a quick video going over number 9 and number 11 from the second set of pages on the homework. Um, in class, I know we only did one example, so again, I always view and hope you do too, right? View the homework as an opportunity for independent practice, okay? So again, I hope you engage with the problem seriously. I picked them on purpose, right? It's good preparation for the upcoming quiz that you'll be having. But I also know that you probably have a couple questions. Maybe you don't feel totally confident at this point in the game, which is why I put together the video. Okay, so if we look at the first one, we're given that -1 plus 2i is a root. So if -1 plus 2i is a root, well then -1 minus 2i is also a root. And that's by the conjugate root theorem. Okay, that's by the conjugate root theorem. Again, in the beginning, I do want you to write that on down. All right, and so in class, I recommended that we write our polynomial, which is x cubed plus x minus 10. I'm just going to call it p of x. And my goal is to write p of x as the product of some unknown polynomial q of x, right? This is like our placeholder. And then because -1 plus 2i is a root of the equation, right, when it's set equal to 0, well, then x minus 1, -1 plus 2i, and the parentheses are really important, okay? And then x minus -1 minus 2i, okay? And so at this point, right, that placeholder polynomial should have two roots in it, right? Because we've already been given 2, we have a degree 4 polynomial, so there must be 2 in that q of x. So what we want to do is we want to distribute out the -1 in each of these factors. So we get x plus 1 minus 2i, and then x plus 1 plus 2i. All right. And the reason we do that is because we get this difference of squares. Okay, we get this difference of squares. And again, the parentheses are really important. So please make sure you write them down. And now we have a squared minus b squared. All right. I think a couple of guys missed the parentheses around the 2i in class when we did a similar problem. And so when we go through, we get x squared plus 2x plus 1 minus 4i squared. All right. So we get q of x times x squared plus 2x plus 1 minus 4 times -1. And then x squared plus 2x plus 1 plus 4. All right. Again, I know some of you can probably do that all in one step. However, right, you want to make sure you don't make simple little mistakes. So I would highly encourage you, at least in the beginning, right, take your time, write everything out, be precise. And so we end up with q of x times x squared plus 2x plus 5. All right, so we now know that our polynomial is equal to some quadratic polynomial. I'm going to call it q of x as a placeholder times x squared plus 2x plus 5. And so to solve for that missing polynomial, I'm going to take my original polynomial. I'm just going to divide by x squared plus 2x plus 5, just as we do when we have to solve for an unknown algebraically and we're multiplying two things together. Okay? So in yesterday's lesson, the start of today's lesson, right, we did a lot of work with synthetic division. If you have something in the form x minus c, right? So we have a linear, it's a binomial, it's linear, and the coefficient of x is 1. Unfortunately, this is a trinomial, so actually kind of rules it out right away. And so what we need to do is do long division. And so we get x cubed. We need to add a placeholder for the x squared term. All right, that's what we talked about that earlier in the unit. And then we get x squared plus 2x plus 5. And so x cubed divided by x squared is x. And then we multiply through, so we get x cubed plus 2x squared plus 5x. And then we flip all of our signs. And so we get negative 2x squared minus 4x, and we bring down the negative 10. So negative 2x squared divided by x squared is negative 2. So I get negative 2x squared minus 4x minus 10. And I can flip all my signs, and I get 0 as my remainder. And you should pause here and tell yourself that is what we want, right? That is what we want. We know that negative 1 plus 2i is the root, negative 1 minus 2i is the root, so they're corresponding factor. We have corresponding factors from them, right? And so the point is that when I divide by the product of those two factors, I should get another factor, okay? And so on the side, or really wherever on the page, on the notes, I was kind of doing it on the side, I think for the video, I'll just do it at the bottom. But essentially what we want to do here is we have x cubed plus x minus 10 equals 0, right? This was the solution we were trying to solve. And we can now write it as x squared plus 2x plus 5, right? That was when we multiplied the polynomials together at the beginning. Okay, that's what we did up here. And now that mysterious q of x, we're going to call it, it turns out it's x minus 2. That was our placeholder. And when x minus 2 is equal to 0, well, I guess to back up, right, the zero product property says that if the product is equal to 0, then either the first one is equal to 0 or the second one is equal to 0. We already know the zeros of the first polynomial, right? It's negative 1 plus or minus 2i. And x minus 2 is equal to 0, of course, when x is equal to 0. So the zeros of this equation are 2 and negative 1 plus or minus 2i. Okay. So I'd say, pause it here, look back. The next question is also interesting. I will do that one as well. For the next one, we're told, right, similar idea. We're told that 3 plus I is a root. And if 3 plus I is a root, well then 3 minus I is also a root by the conjugate root theorem. You won't have to write this again after this lesson, but the conjugate root theorem part. All right, I think hopefully we know that at this point. And so again, strategy is similar, right? P of x is equal to some q of x times x minus 3 plus I, and then x minus 3 minus I. And we distribute that negative. And again, we need to regroup. And so we get x minus 3 squared minus I squared. Perhaps this was a little bit easier, right? Because it's just I squared. There's some coefficient. And so we get q of x times x squared minus 6x plus 9 minus negative 1. And this is q of x squared minus 6x plus 9 plus 1. So it's q of x squared minus 6x plus 10. And so again, this original polynomial we had is now the product of some polynomial times x squared minus 6x plus 10. If we can find the zeros of that placeholder polynomial, then we've got all the zeros, right? And p of x is a quartic, right? It's a degree 4 polynomial. So when I divide p of x by x squared minus 6x plus 10, I should get a quadratic left over, right? Because a quadratic times a quadratic will give me a degree 4 polynomial. And again, I can't synthetically divide here, sadly, because I have a trinomial in my denominator. So I'm going to go, and when you fill out the division house, you need to put the placeholder. That's x squared, and then plus 60x, and then minus 100. And then x squared minus 6x plus 10. And so x to the 4th divided by x squared is just x squared. And something interesting will happen here. So when I flip all the signs, you'll notice that actually both the x to the 4ths and the x cubes cancel out. So remember I'm dividing by a trinomial, so I need to make sure that I have 3 terms, right? So I'm going to bring down the 60x as I always do, but I need to also bring down the negative 100. Okay? And negative 10x squared divided by x squared is negative 10. So you don't have to do this, but I highly, highly, highly recommend it. Put the placeholder. Okay, I guess I've said that word a lot in the video and the unit. And so I get negative 10x squared plus 60x minus 100. And then I can flip all my signs. And I'm left with a remainder of 0. And again, I know there's a lot going on, right? You have to first find what you're going to divide the original polynomial by, right? You've got to get x squared minus 6x plus 10 as a polynomial, and then you have to do long division. But if you get a remainder of 0, there's a pretty high chance that you did everything correctly, which is good. And if you don't get a remainder of 0, go back and start again. Okay? So again, we always want to keep score as we do this. So we had initially x to the fourth minus 6x cubed plus 60x minus 100 is equal to 0. And I figured out that my first polynomial was x squared minus 6x plus 10. And then when I did my long division, I found that that placeholder polynomial was x squared minus 10. And if you think about it, right, well, either x squared minus 6x plus 10 is equal to 0, or x squared minus 10 is equal to 0. And again, we already know from the given information, right, that the zeros of x squared minus 6x plus 10 are 3 plus or minus I. And this one looks a little weird. I think you actually saw it. Similar question earlier in the homework. So x squared equals 10, so x is equal to plus or minus the square root of 10. Please, please, please don't forget the plus or minus. We spent a whole unit on that, and it's come up again. So our roots of this equation are 3 plus or minus I and plus or minus the square root of 10. Okay, so I'll stop sharing my screen. Again, I know that there are a lot of steps going into these problems, right? You have to find that polynomial. In order to do that, you got to figure out what the factors are. You've got to distribute a negative. You got to do difference of squares, and then you have to long divide. So I just want to say, as you're working, right, make sure you move slowly, write out every step. Okay, this is not the time to cut corners. And at the end, when you long divide, if you get 0, you should feel pretty good about where you're at, and then you can just find the zeros of whatever that polynomial are, and then you are good to go. Okay, so that is all I've got. As always, stop by the MRC if you have questions, and I will see you guys in our next class. Thanks.